Ladies and gentlemen, welcome back to our first agenda of day 4 of FNSC today, which is Air Pollution Crisis, which is titled Technology of Controlling Air Pollution. We are lucky to have Dato Serafin Wu, Technical Director of Master Jaya, Greentech, Sdn Berhad, to deliver her talk for today. Please be ready for this session. Here is the biography of Dato Serafin Wu. Dato Serafin Wu has spent the last 22 years working in the sector and obtained extensive knowledge and experience in the Industrial Air Pollution Control System, APCS. She created her own training materials to ensure everyone she trains will have the chance to learn about the most recent APCS technology. Her areas of expertise include local exhaust ventilation, duetting, chimneys, fans, and blowers, material handling, consulting, training, manufacturing, installation, testing, and commissioning of industrial APCS. She has handled various large projects on industrial APCS for various manufacturing and process industries in Malaysia and Asian countries. Dato Serafin, who has been closely collaborating with DOE and IMAS in developing the training modules for DOE and industry for APCS. She is also a certified trainer registered with DOE, IMAS to conduct certification courses to industry and DOE since year 2006. Before we begin, friendly reminder, if anyone has any questions, you may directly ask our guest speaker or you may leave your questions in the chat box during the Q&A session. Kindly remember to mute your microphones during the presentations to avoid interruptions. Without further ado, please welcome Dato Serafin Wu. The floor is yours.
Thank you very much, MC. Okay, very good morning, ladies and gentlemen. Can everyone see my screen?
Yes, we can.
All right, okay, thank you. Okay, very good morning once again, ladies and gentlemen. My name is Serafin, as introduced by MC and from Master Jaya Group of Companies. First of all, I would like to thank UITM for inviting me to take part into this train talks on air pollution crisis. I'm happy to see so many of you joining the event today on a Saturday early morning. Yeah. So, right. So my topic today is on the technology of controlling air pollution, okay, related to air pollution crisis. Time is only 1 hour, so it's a very short time. So I'll try my best to share whatever I can in this 1 hour. After that, or even in between, if you have any questions, just feel free to type in your question in the chat box. Okay, since our topic today is about air pollution crisis, so let's look at how critical or what is the crisis that we are all facing now in terms of air pollution. Because personally, I feel that especially in Malaysia or even in Southeast Asia, air pollution problem, I would say the awareness of air pollution is not that high as compared to like in the European or in the American country. This is taken from the WHO. Okay, what it says here is WHO data shows that almost all of the global population, 99%, breathe air that exceeds WHO guided limits and contain high levels of pollutants, with low and middle income countries suffering from the highest exposure. Okay, so this is something that everyone should really look into it because it's 99%. That means it's affecting almost every one of us here. Okay. Okay, so this is also from WHO report. So how many people die? This is a statistic of how many people die every year. So this one we are talking about every year, yearly. It's not just accumulated. Okay, so this is, we are talking about yearly. Okay, so 7 million people die prematurely every year. So this one we are talking about every year. We're not talking about accumulative. Okay, every year, both household and outdoor. Okay, so 7 million people is a very serious figure, a very dangerous, scary figure. Okay, so this is every year. Okay, let's see. Where is Malaysia? Okay, Malaysia is here. Okay. So out of the total 7 million people death, okay, let's see who is ranked number one. Okay, so number one, over 2 million, okay, is from Southeast Asia. So where is Malaysia located? Where are we located? We are located right in the center of Southeast Asia. Okay, so which means our air pollution problem in Malaysia is also one of the highest risks, okay, among worldwide. Okay, among worldwide. So we are the top champion in the list. And look at who is the last two. Okay, the last, of course, you see here is the light blue color. Light blue color is American. in the region of American continent, South America, and North America. Yeah, then of course, last two is about 500,000, which is from European. If we compare in terms of the area, Southeast Asia is one of the smallest continent, okay, as compared to Europe, as compared to America. But sadly, the truth is, although we, in terms of area, we are one of the smallest, but our air pollution problem is the most serious in the world. Okay, so we have to do something. So I'm very happy that UiTM organized this very meaningful talk, a series of talks that covers not just air pollution, water pollution, waste management. Okay. Yes, let's look at a bit about air pollution. So today in this 1 hour talk, I will focus more on industrial air pollution, okay, about factories and manufacturing plant in Malaysia. Okay. There's a regulation regulated by our Department of Environment. In short, we call DOE. Yeah, so DOE stands for Department of Environment. So there is a regulations that enforce in Malaysia, which control all the industrial air pollution. Okay, the name of the regulation is called Clean Air Regulations, or in short, we call CAR, C-A-R. Okay, Clean Air Regulations was enforced on year 2014, on the 5th of June. Yeah, on the 5th of June, year 2014. So, which is about now we are in the year 2023. Okay, so it's about 8 years. So this year we're entering the 9 years. Okay, so there's one regulation in this car regulation. There are total 30 regulation, not that many, only 30 regulations. So if you have time, you can actually download these regulations from DOE website www.doe.gov.my. It's free of charge. Okay, you can download all the regulations about clean air, about scheduled waste, about water, about effluent. Okay, so one of the regulations mentioned about air pollution control system. Okay, how do we control the air pollution? Okay, especially targeting the industrial premises. Okay, so the regulation 7.1 says every premises shall be equipped with an air pollution control system, or in short, we call APCS. Okay, in accordance with the specification as determined by the Director General. Now, what does this law say? The meaning of this law means DOE has enforced this law, and in this law says that every industrial premises need to install an APCS, or air pollution control system. Now, of course, how to install, what type of air pollution control to install, what about the design? How do you design the air pollution control system? All this DOE has a specific guideline, okay, to install, to design. How do you design the filters? How many filter bags are required? How much water we need to use to control the air pollution? So it's not up to the industry to do whatever they like, okay? Because the law says they must install air pollution control system in accordance with the specification as determined by the Director General. Director General is the Ketua Pengarah of DOE, Department of Environment, or Jabatan Alam Sekitar. All right. So it is very important to have enforcement, to protect our environment, because we are still a developing country. So some manufacturers, just for profits, they might not install air pollution control system if there is no regulations, no law being enforced. Okay. Okay, so there's another regulation called regulation number 2, interpretation. So interpretation basically is what is the definition. So in DOE regulation, what is their definition of air pollution control system? Okay, because regulation 7 says that every factory must install APCS. So what is APCS? Okay, APCS means any facilities designed or constructed for the purpose of preventing or reducing the potential emission that can cause or that causes air pollution, okay, and includes air pollution control system must include Number one, extraction system. Okay, number two, control equipment. Okay, and chimney. Right. So these three key component main system must be included in any air pollution control system. Okay, so let's look at, okay, this is in the BM. Okay, okay, so this is a very simple sketch to show, ladies and gentlemen, what is an air pollution control system. Okay. Now some of the students, if you are studying environmental subjects, I believe you also study about air pollution in your courses. So basic components, we should have about 5 components. Yeah, basic, we will normally have about 5 components in a complete air pollution control system. Okay, let's see, which 5? Yeah, number 1, suction hood. Okay, number 2, ducting. Number 3, back filter, dust collector. Okay, number 4, fan, followed by the last component, number 5, chimney. So these 5 components make up a complete air pollution control system, or in short, I just call it APCS. Okay, so when you go into any factory, okay, or in the future after graduate, or if you're working in a factory now, just take a look at the factory and see whether they have installed this in the factory or not. Okay, if not, then they are not complying to the law. Okay, so every industrial process that generate air pollution, air pollutants, any kind of air pollutants, can be dust, can be gas, can be black smoke, dark smoke, can be fumes, can also be odor, smell. Okay, so these are all classified as air pollutants, right? So all these must install, a suction hood to suck away the pollutant. You must have a ducting. The purpose of the ducting is to transport the pollutant, okay, from the source, from the machine, all the way into the pollution control system. Okay, then number 4 is the fan. Fan is the main suction equipment. And then number 5, we need to release the clean air out to the environment. Okay. Right, now let's look at the technologies. So we know that air pollution control system need to comprise of 5 components. Okay, now this third component here, in this slide I put out as a back filter dust collector. Now, but it doesn't mean every factory can only install back filter dust collector. No. Okay, there are a few options. There are choices for the designer, for the consultant, for the industry premises to install. So depend on the suitability, depend on the application. Okay, so if it's dust particle, we use back filter dust collector. If it's gaseous pollutant, we can use other type of air pollution control equipment. Okay, so now let me share with you what are the choices, or what are the technology available to control air pollution, specifically targeting industrial air pollution. Okay. Right, so here I've categorized into 2 categories. Okay, as you can see, on your left-hand side is the equipment or the technology to control dust and particulate. Okay, untuk habuk for dust particle. On your right-hand side, you will see the type of APCS that factory can install to control gaseous pollutant, smell, odor, VOC. VOC stands for volatile organic compound. Okay, it's solvent gases, for example, benzene, methane, xylene, toluene. These are all classified as a VOC, volatile organic compound. Okay, so make it easy for you. So I put it as 2 main category. Okay, so one category is the type of technology that factory can install to control or to filter dust particle. Okay, so for dust, okay, to control dust particle, we have the types of APCS. Number 1, settling chamber. Number 2, cyclone. Number 3, we have back filter dust collector. Number 4, we have electrostatic precipitator. Number 5, we have wet scrubbers. Now, of course, it's not just limited to this 5. We also have other type of APCS, but these are some of the most common ones, the most commonly used in the industrial, most commonly installed in the factories. Okay. Okay, then on the right-hand side, okay, these are the types of APCS that commonly used in the industry, in the factory, to control or to filter gaseous pollutant. Okay, we have wet scrubbers, we have activated carbon, we have biofilters, and we have thermal oxidizer. Now, okay, if you ask me which one most common, which one is the most common type, type of APCS, type of technology used in the industry, I will tell you. For dust, if you're considering to install something, to design something for the factory, to filter dust particle, the most common one, or the highest efficiency, the most common, very reliable one, is this one, the third one, which is the back filter dust collector. Back filter dust collector. So this is one of the most commonly used type of technology by industry to control the dust pollution. And also it's one of the highest efficiency compared to the others. For gaseous pollutant, in the industry, compared this 4 type of technology, the most commonly used one to control gaseous pollutant will be the first one, which is wet scrubber. Wet scrubber. So I'll explain to you one by one on each one, but I'll focus, I'll put more focus on back filter dust collector, which is a common one for dust, and also wet scrubber in my today's talk. Because these are the 2 most common ones. So you might see this for those who are working in the factory now. I think you might see this in your factory. For those who are studying now, students, in future when you get a job in a manufacturing plant. So these are also the 2 very common type of technology control system that you will encounter. Settling chamber. The first type of APCS, settling chamber. This type of APCS is used for dust, not for gas, not for gas, only for dust particle. Simplest type of air pollution control. There are other names for this settling chamber. You can also call it gravity settling chambers. You can call it gravity collectors. You can call it expansion chambers or outflow chambers. Very simple, commonly used as a pre-cleaner because it's a low efficiency. So we do not encourage factory or industry to just use settling chamber as the only type of APCS due to the low efficiency. How it works? Very simple. Empty box. Let's say it's just an empty chamber, big empty chamber. It's an expanded empty chamber, expanded empty box. What do we have inside? Basically nothing, empty. There's no filter, there's no water spray. So that's why we call it an empty chamber, but it's an expanded empty chamber. We expand the size, to reduce the velocity, to slow down the speed, to slow down the transport velocity. So when the velocity has slowed down, what do you think will happen to the dust? Yes, you're right. The dust will slowly settle. So therefore, we call this settling chamber. Some people call this gravity chamber, gravity settling chamber, because the operating concept is very simple. Let the dust settle by gravity. All right. So you can see here in the center, there's a plate. Now this plate is optional. Some designer will add it. Some designer will just leave it without, just an empty chamber. The purpose of the plate is just like a buffer plate, just to slow down the speed even more. So that to allow more dust to settle by gravity. Now this type of APCS is good for, now what do you think? What are dust? Is it more suitable for heavy dust? Is it better for heavy dust, or is it better for light, fine dust particle? Yes, you're right. This type of settling chamber is more suitable for heavy dust, big particle, heavy particle. So efficiency will be better for heavy dust and big particle. But if the incoming dust here is all fine dust, very light dust, then this type of APCS is not so suitable. Right. Second one, second type of APCS is called cyclone. Cyclone. So cyclone is also commonly used as a pre-collector now. After the new clean air regulation and enforced, I still remember which year. So DOE enforced the regulation, clean air regulation on year 2014. This is the new latest clean air regulation. Now before, before 2014, does DOE in Malaysia, do we have any law? Yes, of course. Yeah, of course. So DOE actually enforced the first clean air regulation on year 1978. Year 1978. So I think before most of you were born. All right. So in 1978, we already have a clean air regulation. Now that was an old clean air regulation, with much loose standards limits. The limits that time was, for example, for dust particle, that time was only 400 milligram. Okay. 2014, DOE has totally changed a new regulation, reduced the dust emission to maximum 150. So from 400 in the 70s, in the 80s, in the 90s, 2000, then 2014, DOE has reduced medium efficiency. Okay, if settling chamber, the previous one, settling chamber, well, I will classify it as a low efficiency, and then cyclone, we will make it, it will be a higher grade. It considered as classified as a medium efficiency. Okay, so also commonly used as a pre-collector. Pre-collector means pre-cleaner. For coarse particle, okay, what is coarse particle? Coarse particle means bigger particle, heavier particle. Yeah, so big particle, heavier particle, yeah, that it's suitable to use cyclones. Pressure drop wise, low to medium pressure drop, very low to medium resistance, not much resistance. Dust particle in suspension flow spirally within a confined space by centrifugal force. So the operating principle of cyclone is mainly using centrifugal force. We spin the dust particle at very high speed. Okay, medium to high efficiency depending. Yeah, so the efficiency of the cyclone will change. Okay, depend on the incoming dust particle size. Okay. So the same cyclone, if we were to fit in just big particle, of course the efficiency can be high. I can reach 80%, 90%. But the same cyclone, if I change the type of dust particle, the incoming dust, I feed in fine dust and very light dust particle, the efficiency might drop. It will drop to say 60%, 70%, or even 50%. Okay. Advantage of cyclone is low cost, same like pre-cleaner settling chamber. Yeah, settling chamber even lower cost. Okay, settling chamber is even cheaper. Cyclone still cheap, considered as low cost, easy to construct, very little maintenance. Yeah, similar to settling chamber, in the cyclone, inside the cyclone, empty, kosong. Yeah, inside the cyclone, we do not install any filter, we do not add any water spray. So basically it's an empty cylinder, okay, round shape. Okay, the difference between cyclone and settling chamber, very important. Cyclone has to be in round shape. What shape? Yes, round shape, tubular, cylinder shape. Because why? The operating principle is centrifugal force, the spinning forces. So therefore, the shape, the casing of the cyclone has to be in round shape. Now, if we design a square, rectangular cyclone, ladies and gentlemen, do you think a square shape can create any spinning centrifugal force effect? Yes, the answer definitely is no, no, no. Okay, so the difference between cyclone and settling chamber, cyclone must be round, cylinder, okay, to create the high speed spinning forces, we call it the centrifugal force. Okay, okay, I have a short video. Let me show you how does the dust spin inside a cyclone. So this transparent, okay, this transparent equipment is a cyclone. So this video I took it from online. But it's very easy, for, very short video, but easy to show the illustration. How does a cyclone works, okay? On your right hand side, this is the inlet. Okay, so incoming, the process that generate dust particle will connect to here on your right hand side inlet. Dust will come in from here. Okay, on top is the clean air outlet. Okay, so again, on the right hand side here, at the side here is the dirty air inlet. Dust coming from here. On top is the clean air outlet. Okay, at the bottom is not for air to go in and out. At the bottom is for the dust to settle down. Okay, so at the bottom, we need to connect to what? Yeah, we need to connect to a dustbin. Yeah, at the bottom, we need to connect to a bin or a drum, okay, or any boxes, enclosed, airtight drums to collect the dust. Okay, so let's look at the video. Right, so this is how a cyclone operates. Okay, so as you can see, the incoming dust spin at high speed. So we call this centrifugal force. Yeah, can you see just now whether the dust is spinning downwards or spinning upwards? So it's very obvious that it's spinning downwards. So therefore, the inlet of the cyclone must always be where? Is it at the top or at the bottom? Yes, the answer is the inlet of the cyclone must always design at the top, highest part of the cyclone, because why? We want the dust to spin from top all the way to the bottom. So the dust will all settle down. Okay, so this is how a cyclone works. Okay, but of course, if the dust is too light, too fine, unfortunately, we cannot trap all or even 90% of the very light dust and of fine dust, because very light dust and fine dust can still escape, okay, from this clean air outlet. Okay, how? Because in a cyclone, so there are two directions of spinning forces. If you look at here, the red color arrow, it will spin from top and all the way down. Okay, dust will drop into the dustbin. But then this centrifugal force, the forces is still there. Okay, although the effect is lighter, smaller, the forces is reduced, but the force is still there. Okay, so these forces will then, once they touch the bottom, it will change the direction to become this green color spinning forces. So the green color spinning forces is spinning from the bottom to the top. So which means this green color outgoing vertical upward spinning forces will then bring the fine dust and the light dust up, escape out of our cyclone outlet. So this is not a good news. Okay, so therefore we say cyclone is not considered as a high efficiency. Yeah, we classify it as a low to medium, I would say. Yeah, depend on how we design the cyclone. Yeah, some cyclone we can achieve medium efficiency, but some cyclone can only get low efficiency. Okay. All right. Okay, next one, let's look at back filter dust collector. Okay, back filter dust collector, another name for back filter dust collector is baghouse, or we call it dust collector, or we can call it back filter. Some factory call it plated filter or cartridge filter. So there are many different names for this type of APCS. Operating principle, use filters. Yeah, use filters to separate or filter dust particle from dusty gases. Is one of the most efficient, most efficient, most cost-effective type of APC equipment. Okay, compared to settling chamber, the one that we covered just now, cyclone, compared to wet scrubber. So if you want to design a technology, a control equipment to filter dust particle, okay, irregardless of whether it's a fine dust, coarse particle, big particles, small particle, heavy dust particle, or light dust particle, back filter dust collector is definitely one of the best choice. Yeah, definitely one of the best choice because it gives the highest efficiency of more than 99%. Yeah, so that means the filter can trap 99% and more, the minimum 99%, up to 99.9% of even very fine dust particulate. So this is one of the most widely used type of technology in the industry now. Okay, not just in Malaysia, whole world, worldwide. Okay, one of the best for dust particle. Okay, so operating principle, very simple, using filter bags. Yeah, use filter to trap dust particle, use filter to filter dust particles. Okay, what type of filters? Oh, various. Yeah, various type of filter materials available. Depend on the application. Yeah, we have filters for normal temperature below 130 degrees C. We have filters for high temperature up to 200 degrees C. Highest can go up to 260 degrees C. Okay, for example, if I use a Teflon filter, a fiberglass filter, so this material can withstand up to 260 degrees C. 260. Okay. For bigger filter area, we can also use this kind of design, a pleated design or a cartridge design. Yeah, so the purpose of these pleats and the cartridge design is actually to increase the filter area. Yeah. Okay, so this is how we install the filter in the dust collector. Externally, you will just see a square box, a rectangular box, a chamber. So internally, inside, we install filter bags. Yeah, install filters. So we have an inlet for the dirty dust to come in, and then we have an outlet for clean air to release out after filtration. So inside, we have filter bags to trap the dust, okay, to filter the dust particle. Okay, so of course, sizes can be custom made. So all the air pollution control system can be custom made, right? Okay, so this diagram just to show you the filters and the filtration process. So this orange color, okay, orange color is the filters, okay, the fabrics that we use. The gray color on the left-hand side is the dust particle. Okay, the dust particle, a layer of dust that is collected by the filter. Okay, so of course, if very, very fine dust particle can also pass through the filter. Okay, but we have a special material. We can add special treatment to treat very fine dust particle. Right, so some features of back filter dust collector. Advantage of back filter is a dry system. Okay, so the dust that we collect will still be recovered in dry. Okay, so for instance, if in a plastic factory, they generate plastic dust, okay, in a cutting process or in a grinding process. So the plastic powder, if we use a back filter dust collector, we can collect back the powder in the original form, in the dry powder form, in the dry plastic powder form. Okay, so this is one of the advantages. But at the same time, back filter dust collector also has some limitation. Limitation is on the high temperature because depending on what filter material is being used. So every filter material has the limitation on temperature. Okay, so the operator must know, they must know what type of filter they are using, and they need to make sure they control the temperature to below, not to exceed the maximum limit. Otherwise, we will have fire or explosion happen. Okay. Of course, back filter dust collector, although is one of the best, highest efficiency, most commonly used, but there are certain applications we do not advise to use a back filter dust collector. What application? Wet, oily, sticky application. Okay, so if the dust characteristic is too oily, too wet, very high moisture content, very sticky, then we will normally not recommend the factory or the industry to use the back filter dust collector. Why? Why do you think back filter not suitable for oily, wet, sticky dust? Yes, you're right. The answer is because it will stick on the bag. It will choke up the filter bag. Okay, our filter will get choked. Okay, so then once the filter is choked, then there's a lot of maintenance to be done. The factory have to stop the process, stop the production, to change a filter, not just downtime. The maintenance cost is high because they have to keep on changing the filter bags. Okay, general recommendation is to change the filter bag once a year. Yeah, generally it's once a year, but depend on the usage. If a very heavy usage, might need to change slightly earlier, faster, maybe 9 months, 10 months. If the usage is not that high, there are some factories, filter bag can last for 2 years, 2.5 years, or some even up to 3 years. Okay, so it also very much depend on the dust characteristic. Okay, if the dust is wet, oily, sticky, definitely filter cannot last long. Yeah, filter will get choked very fast. Okay. As compared to dry dust, definitely dry dust, filter bag can last longer. Okay, pressure drop is higher compared to cyclone, compared to settling chamber. Higher pressure drop means higher resistance. Okay, higher resistance means what? Means we need to design a bigger fan, a stronger fan. Stronger fan means what? Means bigger motor. Yeah, bigger motor. Okay, bigger motor means higher consumption, electricity consumption. Okay. So it's slightly higher than cyclone and settling chamber. For cyclone, settling chamber, the pressure drop we normally is looking at about 50 to about 100 mm water gauge. Yeah, that is for settling chamber. Settling chamber is even lower. Settling chamber normally is only 50. Cyclone is 50 to 100. And then back filter dust collector is 100 to 150 mm water gauge. Yeah, mmWg, mm water gauge. So of course, back filter dust collector must come with an automatic cleaning system. Yeah, because our factory, the technology that we use in the factory, we need to cater for their continuous process, 24 hours running. Yeah, so manufacturing normally they have to run their production 24 hours non-stop. Therefore, engineers who work in the plant, in the factory, sometimes they work in shift. Yeah, morning shift, night shift. Yeah, because why? Because the process cannot afford to stop. They must run 24 hours continuously non-stop. Okay, so ladies and gentlemen, I have a question for you. Now, if we run the dust collector back filter non-stop 24 hours, continuously dust come in to the filter, stick on the filter bag, what do you think will happen? What do you think will happen to the filter? Okay, now let's look at this filter bags. Okay, so inside the dust collector, we have filters installed. So dust will come in 24 hours non-stop. So the fan run 24 hours, suction 24 hours non-stop. So the dust will stick on the filter bag non-stop. Okay, 24 hours continuously. So what do you think will happen to the filter bag after a few hours? Yes, you're right. The filter will be choked, full of dust. Okay, so like this. So this is what will happen. Like this. So after a few hours or a few days of operation, if there is no cleaning, if there's no cleaning, filter bag will be all choked up. Yeah, filter bag will all choke up with dust, full of dust. Okay, then what do you think will happen to the suction? Okay, when the filter is choked, full of dust, what do you think will happen to this incoming suction, the dust? Yes, you're right. Suction will drop, suction will reduce. Once the filter is choked, the suction will drop, the suction will reduce. Then this will create another air pollution problem indoor, inside the building, inside the factory, at the process area. Why? Because the filter is choked, full of dust, and this will reduce the incoming suction. Okay, then when incoming suction reduce means we suck less. Less dust will come in. So this will reduce the suction at the process, at the machinery, at the production area. Then this will also create another air pollution problem. Yeah, indoor air pollution problem. Yeah, so this will because the engineers, the operators who work inside the factory. Okay, so this is bad. So this is definitely violation of the occupational safety and health of the workers. Right. So therefore, we say here, most back filter dust collector must have a filter cleaning system. Okay, so we classified the dust collector using the cleaning method. So there are 3 types of cleaning method. Number 1, pulse jet. Number 2, mechanical shaker. Number 3, reverse air. Okay, what are the differences? Okay, the main difference is the cleaning method, how we clean the filter bag in this dust collector. Okay, number one is pulse jet. Pulse jet, we use high pressure compressed air to clean the filter bag. Okay, again, in a pulse jet dust collector, use compressed air, high pressure compressed air to clean, to blow the filter bag. So we can hear a very strong pouncing sound, high pressure compressed air. The pouncing sound, the cleaning sound sounds like this. Okay. Very strong, very noisy sound, strong blasts of high pressure compressed air to blow, to clean the filter bag. Okay. Second one, using mechanical shaker. Shaker. Okay, let me show you the next slide. Now, this is how a shaker dust collector looks like. Okay, we have filter inside, and we use a shaker mechanism to shake the filter bag. Okay, how do we shake? What type of shaker mechanism? There are two types. One is manual shake. The other one is motor shake. Okay, so we use a motor to shake. Okay, to shake the top part. This top part here, we have a support structure. So we use a motor to shake the filter. Yeah, so this we call a mechanical shaker dust collector. Okay, of course, some very conventional factory, they are still using a manual shake. Manual shake means what? Oh my God, the operator have to manually use the hand, to shake the filter, during the tea break, during the lunch break. So this one definitely we don't recommend because this one very taxing for the operator. High labor, they need to depend on manual cleaning. And if manual cleaning, they can't operate dust collector 24 hours. Okay, they have to stop the filter just for cleaning purpose. Okay. Okay, so this is pulse jet. Okay, pulse jet dust collector. Okay, something like this. So internally we have filter bag. On top of the filter, we have pipes. This pipes is to blow compressed air in. Okay, we use high pressure compressed air to blow on the filters. Okay, so every time compressed air push in, filter bag is being cleaned. Okay. Oh, sorry, I think someone shared the whiteboard. Okay. Let me try to share my slide again. Okay, sorry for the interruption. Someone accidentally shared the whiteboard. All right, so this is a pulse jet. So we use high pressure compressor to blow, clean the filter bag, okay, to release the dust particle. Okay, so internally, this is how we install the filters. Okay, so there are many filters, not just one or two. Could be few hundreds up to few thousands filter bags installed in one dust collector. So depend on the flow rate. So of course, the higher the flow rate, the more filter bag is required. Okay, just a quick video, okay, from online to show you how is the filter being installed inside this collector. Got into the filter bag. This is the filter bag. A long one. Into the hole. This hole we call the selfie. From here, you need to install at the hole airtightly. Install the bag, make sure it's airtight. Next, slot in back pages. Okay, so this is how we install the filter. So first we slot in the filter, the white color, this is the filter. Okay, and of course the top part here has to be airtight to prevent any dust leakages. Then internally we have a support structure to support the shape of the filter. So this component we call it back cages. Okay, so animation to show you how does a pulse jet back filter works. Okay, so first of all, on your bottom left-hand side, this is the incoming dust. Okay, dust coming from the ducting. We call this inlet ducting from the process, from the machine, cutting process, grinding process, from the furnace. Okay, so dust will come in, dust will stick on the surface of the filter bags. So that this is how the dust is being separated. Okay, use filter to separate the dust. Okay, use filter to trap the dust particle. So clean air, filter air, okay, will pass through the filter, go up, okay, go to the clean air chamber on top. Okay, then the clean air or the filtered air, okay, will release, escape, and release out. So here we have an outlet. We call this a clean air outlet. Clean air outlet is normally connected to a fan, suction fan, and then to a chimney. Okay, now inside, on top of the clean air chamber, we have pipes. These pipes is for compressed air to come in, to blow in, to supply in compressed air, to blow on the filter bag. Okay, so once compressed air is blow on the filter bag is being cleaned. Okay, so compressed air purging, blowing or pausing on the filter. Now, of course, every time when we blow compressed air, the filter will actually expand. Yeah, filter will expand, so that we have vibration, okay, for the dust to release, okay, from the filter. So the dust will drop. Dust particle accumulator on the filter bags will get detached from the bags and fall into the hopper after pulse jet cycle. Pulse jet cycle means the compressed air cleaning cycle. Okay, hopper. Now this component at the bottom, the pyramid shape, the cone shape at the bottom is called hopper. Okay, so the dust will drop into the hopper and then discharge out. Now, of course, we don't let the dust just drop out on the floor like this, no. So in the factory, we will install a dustbin, proper dustbin to collect all the dust particle. Okay, so this is how a bag filter dust collector works. Okay, so this is one of the most important technology, most widely used kind of technology in the industry now to filter the dust particle. So therefore, I will spend more time on this because this is the most commonly one that you will see in the factory. Okay. So suitable for 24 hours continuous process. Okay. Means what? Means during the pulsing, during the cleaning, when the compressed air blow in, we do not need to stop the suction fan. Okay. We don't need to stop the fan in order for the compressed air blowing. No. Suction and compressed air cleaning will operate together concurrently. Yeah, concurrently. Therefore, we say this pulse jet dust collector is suitable for 24 hours operation, continuously non-stop. Okay, it will not affect the production downtime, and the production don't need to stop just for the purpose of cleaning. Okay, so this technology is designed for 24 hours continuous process. So therefore, this is one of the most commonly used type of technology. Okay, applied in almost every industry for powdered and granulated material, high efficiency, 99% and above. You name it from A to Z, all kinds of powders. Yeah, our group Master Jaya, we have designed and supply install more than 1,000 sets of bag filter dust collector to various industry, A to Z, you name it. Yeah, aluminum, asbestos, carbon, cement, ceramic, chemical, flour, food industry, glass, pharmaceutical, plastic, sugar, tobacco, wood, metal processing, and many, many others. Yeah, many, many others. All right, so here, okay, just want to share some of our installation, okay, of bag filter dust collector in a factory. Okay, so there are two types of APCS technology installed here, A and B. Okay, A and B. Now, A is a pre-cleaner. Yeah, A is a pre-cleaner, empty chamber, no filter inside here. A is an empty chamber, pre-cleaner. B, okay, inside B, we install filters. We have filter bags. Okay, so ladies and gentlemen, do you know what is the name? What are technology? What is A and what is B? Okay, answer is yes, A is a settling chamber. Yeah, rectangular shape. Okay. Now, can A be cyclone? Yeah, no, because like I said, cyclone has to be round, round cylindrical shape. So this is a rectangular chamber. Inside is also rectangular shape. So it's a settling chamber. B is a bag filter. Okay. Now, what about this one? Okay, we have A and B, two different technology, two different type of APCS, both for dust particle. Okay, B, just to give you a tips, B is a pre-cleaner empty cylinder. Yeah, B, inside B has nothing, no filters. Okay, B is empty. So do you know what is B? Okay, A, inside A, we have filters. Yeah, we have filters. So I think you can guess already by now what is A, what is B. Yes, you're right. A is a back filter dust collector. B is cyclone. Now, so the dust will enter which one first? Will the dust go into the filter first, then only to the cyclone? Or the dust go into cyclone first, then to back filter? Yes, answer is definitely the dust will enter cyclone first because cyclone is a pre-cleaner to remove the heavy dust particle and the big particle. Okay, the fine dust from outlet of the cyclone, fine dust will then escape. Then only we go into a back filter to remove the balance, 99%, 99.9% of the fine dust all trapped by the filter. Okay, so then clean air escape. Okay, so this is one of the very common type of technology installed in the industrial premises. Okay, the next type of APCS that I would like to share with you is wet scrubber. Okay, so due to time constraint, I can only share more on this back filter and scrubber. Okay, wet scrubber is also another very common type of technology installed in the factory. Okay, the difference between wet scrubber and dust collector, back filter dust collector is one is dry system. Okay, back filter dust collector definitely is a dry system. Used for dust filtration, yeah, mainly for dust filtration. Wet scrubber, no filter. They don't use filter. There's no centrifugal for spinning. It uses liquid. It uses water. Okay, we spray water in a wet scrubber. We supply water. We pump water in a wet scrubber. We use water to absorb, to remove the pollutants. What are pollutants? Both. We can use to treat gaseous pollutant, like acid gas, alkaline gas, sulfuric acid, hydrogen chloride, chlorine gas. Wet scrubber can be used to trap dust particle, and at the same time also can be used to trap gaseous pollutant. Yeah, 2-in-1. Can be low, can be high pressure drop, because wet scrubbers, there are many different types of wet scrubbers. Yeah, there are many different types. Disadvantage of wet scrubber is definitely, yes, you need water. Yeah, you need continuous supply of water, because we use water to absorb the pollutant. Okay, it's an absorber basically. So therefore, wet scrubber can also be called absorber. Okay, use liquid water to absorb the pollutant. Disadvantage is wet scrubber will produce slurry. Wet scrubber will produce wastewater. All right. So factory who install wet scrubbers, they need to think of how to treat the dirty water, the effluent, the wastewater, the slurry that is produced by wet scrubbers. Okay, so wet scrubbers can help us to solve our dust problem, our gas problem, but it generates a new problem. It generates wastewater. It generates effluent. It generates acidic water. Okay, so therefore, factory who install wet scrubber, this dirty water, the effluent, the wastewater that is generated in the wet scrubber must be treated. Yeah, has to be treated before it can be drained out to the public drain. Okay, so factory definitely they cannot just drain out the dirty water, the slurry, the acidic water, the sludge to the drain after, right immediately from the scrubber. No, cannot. Cannot. Okay. So this is how a scrubber looks like. Okay, so we have an inlet for the pollutant gas to enter or dust particle. We have an outlet for the clean air to exit out to the fan, to the chimney. Internally, we have several components. We have spray nozzle to spray water. Okay, we use water to absorb the incoming pollutant, gases, acid, ammonia gas, chlorine gas, dust particle, all kinds of gaseous pollutant. Okay. Wet scrubber is more commonly used in the factory to trap gaseous pollutant. Gaseous pollutant. Okay. Or with also to trap some dust particle which are not suitable to use filter. For example, too oily dust, too sticky dust, okay, too wet dust. Okay, if I use a filter, my filter will get choked very fast. Okay, so another option is to use a wet scrubber. Okay, sometimes to increase the scrubber efficiency, we will also add this component called packing inside the wet scrubber. Packing looks like this. Okay, the purpose of the packing is to increase the absorption surface area. Okay, so with this packing, it will again increase the efficiency of wet scrubbers. Okay. All right. I think I'll stop here because the other type of APCS, the other technology, they are not so popular, not so commonly used. Okay, maybe I just go through very quickly. Now, ESP is an electrostatic precipitator. It's also another technology, but using high voltage power supply. Okay, we use high voltage power supply. On top, this is an ESP, electrostatic precipitator. On top, we have transformer. We have transformer on top. So we use transformer to supply high voltage power supply inside into the ESP. So this is the dust incoming, dust inlet. On the other side is the clean air outlet. So ESP is used to filter dust particle. Not for gas. Not for gas. So internally inside, ESP is not common, very uncommon, not popular at all. Only certain industry like, for example, cement plant, power plant, glass smelter, nowadays palm oil mills start to install ESP. But in the cement plant and even in power plant, they are starting to convert, to upgrade the ESP to back filter dust collector. Because if comparing efficiency, reliability, back filter will have a slight advantage over ESP. So therefore, some of the cement plant in Malaysia, also worldwide, internationally, 30 years ago, 40 years ago, 20 years ago, they installed ESP. Okay, but nowadays, most of the cement plant, power plant, they try to convert and upgrade and change it to a better technology, which is a back filter dust collector. Okay. Advantage of ESP is there's no filter. There's no water spray inside. So therefore, it is suitable for high temperature application. Okay, so inside the ESP, we have a positive and negative electrode because electrostatic charges basically is using the positive and negative charge concept, electrostatic charge concept to collect the dust particle. So inside the ESP, we have a positive plate and the negative discharge electrode, something like this. Okay, so in the center, this is the negative electrode. We call the discharge electrode. Okay, at both sides, left and right, we have plates, normal metal plates. The plates is we call the positive electrode. Okay, so inside the ESP, we have negative electrode, we have positive electrode. So this is how it looks like, high voltage power supply. So we use this high voltage power supply, negative electrode, to charge the incoming dust. Okay, to charge the incoming dust. So when the dust become negatively charged, the negative dust, okay, like here. So this is negative. At the side, left and right, we have positive plate. Okay, what do you think will happen to the negative dust? Okay, electrostatic concept principle says opposite charge will attract. That means if you have one positive, one negative, it will tend to stay together. It will attract together. So what happens is dust coming to the ESP, we charge the dust, make the dust become negatively charged. Then the negative dust will then be attracted and stick on the positive plate. Okay, so this is how the dust is being removed or trapped or filtered in a ESP. Okay. Okay, last one, we have activated carbon tower. So it's in a chamber or in a cylinder or in an empty boxes, we install carbon media. Yeah, carbon media. Okay, so we have similarly we have the dirty air inlet. So the dirty air, pollutant air will pass through the carbon tower, the carbon media. Then clean air will be released out. Okay, from the clean air outlet. So this is the type of carbon we use. We call this activated carbon. Yeah. So it's a treated carbon basically. Yeah. We treat this. We use this carbon as an adsorber to absorb the gaseous pollutant. Right. So activated carbon is used to absorb or filter gaseous pollutant. Okay, not for dust. Yeah. So we don't use activated carbon to filter dust particle. No, activated carbon is used to absorb gaseous pollutant. Okay, smell, for example, odor, smell, or some of the acid gases. Okay, can be treated using this type of activated carbon technology. Okay, we also have carbon in this panel. Okay, like a filter, like a material, filter fabric material, like a paper material. All right, okay, that's all on my sharing today. All right, so I think time's up. All right, so thank you very much once again, ladies and gentlemen, for your kind attention. It's a very short time that I only have 1 hour today. I hope what I shared today with you has benefited you. And if you have any questions, feel free to contact me. Our company is a Master Jaya Group, established since 1983. So this year we are celebrating our 40 years anniversary. We are turnkey designer, consultant, contractor, trainer, installer, project management for full range of industrial air pollution control system. Okay, feel free to contact me if you have any further questions, need any help for your factories. Okay, you can save my phone number, my email address. Okay. Okay, thank you very much, ladies and gentlemen.
Okay.
I will pass over to MC.
Okay. Thank you. Thank you so much, Dato Serafin Wu, for sharing just now. Now, we will have a Q&A session. Participants are welcome to direct your questions to our speaker. So we already have question. So the first question is from Dewi. The questions are, what are the best PPE for both APCS exposures?
Okay, very good morning, Dewi. Thank you very much for your question. Okay, what are the best PPE? Good question. Safety and health, related to occupational safety and health. Personal protective equipment. And of course, definitely is a mask. Okay, definitely is a mask filtration that you have to wear at your, just like the normal mask that we are wearing nowadays. But of course, the mask that we wear normally, everyday, daily, is not suitable for very fine dust and gaseous pollution. So the mask that the PPE mask, there are several grades. Okay, there are many different grades of masks. Like for instance, for dust particle, we can wear N95. Okay, and every mask they will have their the technical specification sheet to spell out what is the dust particle micron size that they can trap, they can filter. All right. So what type of PPE? It all depend on what type of pollutant. Okay. So before you enter a plant, a factory, a lab, okay, first thing we try to find out what type of pollutant is in the lab, what type of pollutant is in the plant, in the process. So if it's just purely dust particle, okay, we can use N95. But if it's a gaseous pollutant, for example, or if it's an ammonia gas, then definitely N95 will not help. So we have a special mask, okay, for different type of gaseous pollutant. Yeah, so 3M, company 3M, they are very popular selling this kind of PPE mask. Okay, but they have many different type of filter, different grades, okay, for different type of gaseous pollutant. Right? Okay, I hope this answer your question.
All right, thank you, Dato. So next question is from Norizan. So the question is, how about the cost of installation of APCS, is the dust collector and wet scrubber is cheaper since it is widely used?
Okay, thank you very much to Norizan. Good question. Cost of installation of APCS. Yeah, this is the most common question asked in almost every seminar. Well, if comparing the same airflow rate, now first of all, the cost of a dust collector or scrubber will change, depend on the airflow rate. Okay, depend on what is suction that we required. Of course, the higher the airflow rate, the more expensive the dust collector and the scrubber. Okay, if it's higher temperature also the cost will be higher. Okay, why? Because we have to use high temperature resistant motor, we have to use high temperature resistant filters, even the gaskets that we use has to be temperature resistant. All right, so the cost is very much depend on the flow rate, number one. Number two, the temperature. Okay, of course, also very much depend on where do we install the scrubber. Is it very near to the machine? Is it very far away from the machine? Because the ducting, the ducting size, of course, the longer the ducting, the higher the cost. Okay. Let's say we compare apple to apple. Okay, same location, same duct size, same flow rate, same fan, same temperature. Comparing back filter to wet scrubber, actually the price difference is not that much. Not that much difference for both. Yeah, they are more or less the same. Yeah, more or less the same. Okay.
Okay. So we have another question from Devi. She asked about for workers who exposed with air pollution and etc. working at incinerator plant, does DOE have specific guideline on health test screening for the workers?
Okay, good question, Devi. Yeah, this one for workers. Yeah, this one is for workers testing. This is not under DOE. Okay, DOE is Department of Environment. Okay, so the focus, so when they enter a factory, when they inspect a factory, they do enforcement check on the factory. They will check on the environment, but which environment? Outdoor environment. DOE focus more on the checking, inspection, enforcement of outdoor environment. Now, for indoor working environment, we have another different department called DOSH, Department of Occupational Safety and Health. Yeah, DOSH, D-O-S-H, Department of Occupational Safety and Health. Or they also call it JKKP in BN in Malay. JKKP, Jabatan Keselamatan dan Kesehatan Pekerja. Okay, so that department, DOSH, when they check, enforce, visit the factory, then yes, they will check about the indoor working environment. Is the indoor clean or not? Is the suction good or not? Is there a lot of dust, smoke, smell inside the factory that will affect the safety and health of the workers who work in the incinerator plant or any plant? Yeah. Yes, DOSH does have a guideline. They have the limits, they have the standards of what is the maximum indoor, the dust particle in the inside working environment, the ammonia gas, the chlorine gas, all kinds of pollutant. DOSH does have the guideline. DOSH also have the standards. Okay, so the industry, yes, industry need to do this kind of yearly monitoring. Factory, they need to monitor what is the indoor air quality. Okay, so you see the difference between DOSH and DOE is DOSH look after the working environment, the safety and health of the workers. Oh, is the workers suck in a lot of dust? Is the indoor working environment safe for the workers or not? That is under DOSH. Yes, DOSH has the standard and the guideline. Okay, factory have to comply. DOE requires the factory to also do a yearly test, but not on the workers, on the gas that the indoor air. DOE is Department of Environment. Okay, they focus more on outdoor environment. So DOE test is to test the chimney air quality. Okay, what is air quality? Coming out from the chimney, from the exhaust, released out to the environment. That is under DOE. Okay. Yep. Okay. Thank you, Devi, for your question.
Hope it answers your question. So next question will be from Nur Akila. The question is, may I know, is there any specific materials and size of filter bag for dust collector application?
Thank you very much, Akila. Very technical question. Yes, there is. Is there any specific material and size of filter bag? Yes, there is. Yeah. We have various type of filter material for different application, for different dust micron size, for different corrosion resistant, chemical resistant. Okay. Of course, the most common filter material used in the most of the industrial now is polyester. Yeah, polyester filter. Polyester very commonly used, but they have the temperature limitation of maximum 130 degrees C. Yeah, so we have many. We have many different. We have Normax, for instance, Normax for a higher temperature up to 200 degrees C. We have for very acidic, corrosive condition, for very fine dust particle, we can use Teflon, PDFE filter material. Okay, so yes, there is a different filter material, different spec for different application.
All right, so moving on to the next question is from Norizan again. So she asks, is the dust collected from dust collector will be categorized as schedule waste, or depending on the industry types? How is the disposal of this waste?
Very good question, Norizan. Very sharp. Yes, you're very observant. You're right. The dust collected from the back filter dust collector or from the cyclone or from the settling chamber or ESP, yes, the dust can be schedule waste or might not be schedule waste. So DOE, there's a regulation. So I believe last 2 weeks, we have another speaker, Puan Masri Ayu. She spoke about the schedule waste management. So in her talk, she also mentions about the schedule waste. So DOE have a regulation for this schedule waste. So in the schedule waste regulation, DOE has a code, a list of code, SW code, the schedule waste code, okay, to categorize the type of schedule waste. Yes, so the dust that the factory collect from their dust collector, the dust bin, they need to do one kind of test. They need to test, they need to send up to the lab to do analysis, to we call this the waste characteristic study. Yeah, waste characteristic study, to study what is the content, what is the ingredient inside the dust powder. Okay, so if let's say from the analysis result shows that, oh, this dust is classified as schedule waste, which waste code SW102 or SW422, then definitely the factory need to dispose this schedule waste according to DOE regulation. Yeah, so if it's a schedule waste, factory cannot just dump it in a normal dustbin. No. Yeah, if it's schedule waste, factory need to handle it very carefully. Yeah? They need to dispose it to licensed contractor. Okay, only licensed contractor. Licensed by whom? Licensed by DOE. Okay, only contractor with DOE approval, DOE license can collect schedule waste, can treat schedule waste, can recycle, can recover, or can dispose schedule waste. Okay, so factory that collect dust from dust particle, if it's classified as schedule waste, they need to send the waste to licensed contractor with DOE license. Okay, so in the licensed contractor factory, they will have the equipment to treat the waste, to either dispose the waste or to incinerate the waste, or if it's a precious metal, like for example, handphone e-waste. In our handphone, we still have precious metal. You know, we have gold, we have silver in our handphone. Okay, so your unused handphone, you can actually look for this kind of a waste collector, licensed waste collector. Okay, they will recover, they can recover the gold and the silver from our handphone parts and components. Okay, so I hope this answers your question, Norizan.
Okay, thank you. So due to time constraint, we will have two last questions from Shafiq. So first question is, for dust collected from dust collector, can it be diluted to IETS?
Okay, good question. Dilution is not allowed under the law. Yeah, dilution, whether it's air dilution, water dilution, is prohibited under the DOE regulation. Yeah, in the air regulation, in the water regulation. So definitely answer is no. Yeah, answer is definitely a no for dilution. Okay.
Okay, so the last question, for dust collector, if the final filter is HEPA filter, prior to exhausted to environment, is it still requires chimney and competent person? Few dust collector have HEPA as its final filter.
Okay, good question, Shafiq. In the clean air regulation, in the first few slides that I share, under regulation 2, interpretation, DOE definition of air pollution control system is an air pollution control system must comprise of three main components. Number one, extraction system. Number two, control equipment. Number three, chimney. The third one is chimney. So it is specified under clean air regulation, regulation number 2. All right. So therefore, DOE recommendation is definitely to still have a chimney after the dust collector and HEPA filter. Yeah. Why is it like this? Because you see, our filter will get choked. Our filter will have wear and tear problem. So after using it for, let's say, 9 months, 1 year, or 2 years, our filter will have wear and tear. Wear and tear means there will be holes. There will be holes at the filter. So once we have wear and tear problem, dust will fly out. Dust will escape. Dust will leak out. So if we do not have a chimney to direct the clean air out of the building, then all the dust that leak out from the filter will all circulate inside the building. Then this could be very dangerous for the workers who work inside the enclosed building. Right? So therefore, DOE, even DOSH, who look after the safety and health of the workers, even DOSH also highly recommend to have a proper exhaust outlet. Okay, because in DOSH, in the definition of DOSH, in an LEV system, local exhaust ventilation system. Okay, so factory need to install LEV system to protect the worker safety and health. So in the LEV system, one of the component required is an exhaust outlet. Yeah, in an exhaust outlet. So definitely, if according to DOE, industrial practice, it is highly recommended to still have a chimney. Okay. Now, in a question about competent person, yes, the answer is yes, because as long as the factory has air pollution control system, for back filter or scrubber, definitely yes, they need to have a competent person because it is stated under the law, under clean air regulation, regulation number 7. Yeah, regulation 7 says that the factory, okay, they are under 2. Which one is under the clean air regulation, regulation number 7? The other one is under EQA, Environmental Quality Act 1974, under section 49A. Okay, both in the section, also in the regulation, says that factory need to employ a full-time competent person to take care, to supervise the operation of the air pollution control system at all time, during the operation. Okay, at all time during the operation. So irregardless of whether it has a chimney or not, okay, as long as you have a filtration equipment, you have a scrubber or back filter dust collector, yes, you need to have a competent person to operate, to manage, and to take care of it. Okay.
All right. Thank you so much, Dato Serafin. And thank you everyone for actively participating in the Q&A session. So we'll move on to the next part. We will be having an exciting session for the participants. Please get your mobile phone ready to enter the quiz. Participants can scan the QR code to join the quiz. Winner of this quiz will be given prize. Do make sure you are trying your best. All right. 5 minutes will be given to the participants to enter the quiz. Good luck, everyone. We are still waiting for the participant to join. Okay, we will start the quiz now. I will see who's going to be for this session. Is it going to be the same person? At the moment. Okay, so the leaderboard shows Hooi as a top scorer. You can beat him. For your information, the winner for this quiz will be given prize. So make sure to do your best. We're giving prizes to those who win, but only the top scorers. It's still Hooi at the top, so we'll see who's going to beat him at the end. Currently is still Hooi. So let's see if those at the bottom can beat him. There's Jaya, Amira, Chazmi. Come on, everyone. You'll be given prizes, so do your best. Oh, Amira has beat Hooi, so let's see if she can still stay on the top. Jaya has beat Amira. Seems like it's a battle between Amira and Jaya. Kaijun has beat Jaya, so seems like it's gonna change anytime soon. It's a battle between Amira and Kaijun. Jaya has beat Amira, so he is going to be the top scorer. Pretty unpredictable at the moment. Still Amira at the top. Dia has beat Amira. So, okay. It looks like Dia has gotten every questions right. Currently, it's still Dia as the top scorer with score of 17410. Let's see who can beat her. We will end the quiz in a few seconds. Okay. So we will end the question now. All right. So you can see that the winner for this quiz is Dia. Congratulations to the winner of this session. Please contact our team later. Before we end our first session for today, all participants are required to turn on your cameras for our first photography session. I will pass the floor to the technical team.
Okay, everyone. Hello, everyone. Please get ready to open your camera and get ready for the photography session. Okay. Okay. 1, 2, 3, smile. Okay, one more. 1, 2, 3, smile. Okay, last one, freestyle. Okay, 1, 2, 3, smile. Okay, thank you everyone for your cooperation, and I will pass this back to Wani.
All right, thank you, Mahira. So towards the end of the quiz, it remarked our first session had ended. Once again, a big thanks to Dato Serafin for the insightful talk and everyone for being participating in this session. Now, we will wait for Professor Kenji Sugimoto to join our webinar.
So I will share.
Okay.
Sorry. Okay.
Okay, we will start now. Assalamualaikum and konnichiwa, everyone. Welcome back. It's good to see all of you again. In this session, we are very fortunate to have Professor Kenji Sugimoto, Dean Department of Material Engineering from National Institute of Technology, Ube College, Japan, to give us more insights about blue carbon storage. So here is the biography of Professor Kenji Sugimoto. Professor Kenji Sugimoto is a well-known chemical and biological engineering lecturer in National Institute of Technology Ube College and ITUC Japan. His research fields are mainly in environment and chemical engineering. He has a wide knowledge and experiences about marine environment. His research subjects are mainly focused on study on the restoration of the ecosystem on the artificial seagrass bed and changes in dominant species of seagrass bed after natural disturbance. He also involves in various research articles about marine ecosystem. Now the presentation is about to begin. kindly remember to mute their microphone during the presentation to avoid interruptions. Without further ado, I would like to humbly welcome Professor Kenji Sugimoto to the stage.
Thank you for introduction. So I will share PowerPoint. Can you see the PowerPoint?
Yes, we can see.
Thank you. Thank you for your introduction. So hello everyone. My name is Kenji Sugimoto, National Institute of Technology, Ube College in Japan. Today, I will talk about blue carbon storage. Let me introduce myself a little. My major is chemistry and biology, especially marine biology. I have been researching seaweed and seagrass bed about 20 years. Sea plants, including land plants, absorb carbon dioxide in seawater and carry out photosynthesis. In October 2009, a report by the United Nations Environment Programme named the carbon capture is marine ecosystems such as seaweed beds and shallow water, blue carbon, and represented it was a new option. Marine ecosystems that segregate and store blue carbon include seagrass beds, seaweed beds, wetlands, tidal flats, and mangrove forests. And these are called blue carbon ecosystems. So this is an image diagram of a carbon cycle. The units are billion tons of carbon per year. The amount of carbon emitted from the burning of fossil fuel by factories, automobiles, etc., is 9.3 billion tons per year. Of that, 4.5 billion tons remain in the atmosphere. 2.2 billion tons will be absorbed by forests on land. 2.6 billion tons are absorbed in coastal areas and oceans. Today's story is about 1.1 billion tons of coastal waters out of 2.6 billion tons. This is carbon flexes in the oceans. The flow of carbon dioxide across the air-sea interface is a function of carbon dioxide solubility in seawater. The amount of carbon dioxide dissolved in seawater is mainly influenced by physical chemical conditions and biological processes, primary production. The solubility pump and the biological pump enhance the uptake of carbon dioxide by the surface ocean, influencing its values of dissolved carbon dioxide and transferring carbon to deep waters. All these mechanisms are strongly connected, balanced, and influential to the ocean's capacity to sink carbon. The net effect of the biological pump in itself is to keep the atmosphere concentration. So what is would be it? It is a balance. Sorry. No. Okay. So have you ever heard of blue carbon? Blue carbon is a term or carbon captured by the world's ocean and coastal ecosystems, seagrasses, mangroves, and salt marshes along our coast capture and hold carbon, acting as something called a carbon sink. the big picture of blue carbon is one of the coastal habitat conservation. When these systems are damaged, an enormous amount of carbons is emitted back into the atmosphere, where it can then contribute to climate change. So protecting and restoring coastal habitats is a good way to reduce climate change. So when we protect the carbon in coastal systems, we protect healthy coastal environments that provide many other benefits to people, such as recreational optionalisms, storm protection, and nursery habitat for commercial and recreational fisheries. So this shows the carbon cycle in the sea. The function of the seagrass bed is, including seaweed bed, is to absorb carbon dioxide, fix it organic carbon in the seagrass body, and store it in the sediment. In order to lower the concentration of carbon dioxide in the atmosphere, it is necessary to lower the carbon dioxide concentration in the seawater by storing it in the sediment. So this is our research target. So we are researching from shallow tidal flood to deeper reef in coastal areas. We are focusing on seagrass and seaweed beds in particular. So in our research site, seagrass beds are distributed as the species Zostera marina, Zostera japonica. On the other hand, seaweed beds are distributed variety of algae and mainly focus on sargassum and chrome, one of the comb species as indicators. So seaweed and seagrass bed have a community with a dense expansion of large marine plants such as algae and the Zostera marina. So they contribute to the purification of water quality and maintaining biodiversity. So our goal is reproduction of seagrass and seaweed beds and gathering of useful fish, maintaining biodiversity within the seagrass and seaweed beds. Our purpose is to understand the growth conditions of seagrass or seaweed and evaluate that growth. So environmental improvement to eliminate growth inhibitory factors to relieve useful and inexpensive materials for making seagrass seaweed beds. To clarify why the restoration of seagrass seaweed beds is not progressing in Japan. This graph shows changes in seagrass or seaweed bed and recreation area in the Seto Inland Sea in Japan. In 1916, the seagrass bed, which was 23,000 hectares, decreased to less than 1/3 in about 10 years and has not recovered. On the other hand, reclamation has been done in the Seto Inland Sea since 1970. So next, I'd like to talk to understand the growth conditions of seagrass and evaluate that growth. So this figure shows the physical factors of distribution and growth of seagrass. So we think 3 points. So one is the seagrass bed, which supplies should be located in the neighborhood. Two, it is being in the hydraulic conditions to which seeds are supplied. Three, seagrass habitat suitability. Habitat suitability is physical and chemical factors. So we compared environmental conditions between seagrass bed and bare area. So this is our main study site. So Iwakuni in Japan. So Iwakuni is located near Hiroshima. So this air photograph is our study site. So seagrass distribute about 150 meters from the shore. So seagrass on Iwakuni are two species. So one is Zostera japonica, other is Zostera marina. So Zostera japonica distributes from middle intertidal zone to subtidal zone. So Zostera marina distributes from low intertidal zone to subtidal zone and deeper than Zostera japonica. So shoot height of Zostera marina is higher than Zostera japonica. So Zostera japonica is similar to Lupia. So Lupia doesn't distribute in Japan. Basically, distribute around in US. So this graph shows seasonal water depths and percentage of seagrass occurrence during February 2004, 2007, and October 2013. So in Japan. So red symbol is Zostera marina, and blue symbol is Zostera japonica. So x-axis is water depth. So in the shallower places means so the plus 210 around here. So here so in the shallow place, the appearance rate of Zostera japonica was higher than that of Zostera marina. But as you go deeper, you can see that Zostera japonica was no longer distributing. So this graph shows change in the occurrence and this density of seagrass at two optional water depths during February 2007 and October 2030. So red symbol is Zostera marina and blue symbol is Zostera japonica. The density of Zostera marina was more than 100 shoot per square meter, except for February and April 2012. So although it is not shown in this graph. This was no Zostera japonica in 2007. However, the shoot density of Zostera japonica increased after December 2010, and that decreased after February 2012. So in this study site, the shear stress was reduced in deeper water under calm water conditions, diatoms, and sediment adhere to the leaves of Zostera marina and Zostera japonica. This picture shows ghetto pots, the clam and mobile brown algae in the study lines. There is a possibility that they affected the distribution of Zostera japonica in the subtidal zone. So this picture shows a photograph in Hiroshima Bay. So there are several bare areas between the shore and the offshore seagrass beds. And the seagrass does not grow continuously. What is the reason? It is very important. So we will distribute these bare area. So the purpose of this part of study, uh, so to investigate the long-term change and seasonal change of the bare field formed inside the seagrass bed and clarify the cause of bare ground formation. So we decided to investigate the physical environment such as the bottom sediment and the flow of seagrass bed and the bare area. So, and we transplanted and seeded at the bare area to clarify the cause of bare ground formation. This side, gray is seagrass bed. So especially Docera marina and Docera japonica. So we researched 5 lines and we transplanted and seeded test in bare area. So when we research these areas, we dive to check the seagrass density and seagrass height and sometimes we got the seagrass so analyze the measured the weight. So we took photographies using the drone. So from November to 2014 to February 2017. So we analyzed where those marina distribute. So basically using the software and the name is Adult Imagine, very, very expensive software. So we analyzed this picture, seagrass distribution by image analysis from November 2014 to February 2017. So green area is seagrass bed and the white area is bare. So these pictures are underwater conditions. Although the range is only just 30 meters, the sediment conditions are completely different. So this graph shows changes in the amount of seagrass area and bare area. So green is seagrass area, red is bare area. So seagrass distribution range expands during the overgrowth period. So however, there is no variation regardless of the period in bare area. So this graph shows Docera marina and Docera japonica density results. In fall 2016, a large amount of feeding fish appeared. So there are a lot of feeding damages. So as they did in 2011. So we hypothesize that both times they ate the upper portion of the seagrass, especially Zostera marina compared to Zostera japonica. So the graph shows Zostera marina and Zostera japonica should hate results. So in fall 2016, the Zostera marina shoot height has been shortened due to damage of food. But in March 2017, seedlings of Zostera marina distributed. So this graph shows number of seeds in November 2015, a range of 15 centimeter times 15 centimeter was sucked up with a jet pump and sieved through a 1 millimeter sieve. Places where the density of Zostera marina and Zostera japonica were high, many seeds of Zostera marina and Zostera japonica in the bottom sediment were found. These graphs shows result of transplanting in June 2015 and seeding test in November 2015. So these are underwater photographs at that time. So at 2 months after the transplantation, the shoot densities of the Drosera marina has decreased at all points, but the bare area almost disappeared. So on the other hand, germination of seeds seeded in an seagrass bed was confirmed, but it could not be confirmed in bare area. So these graphs show flow conditions. So we installed the device on the bottom. So from April 2015 to November 2016, the flow velocity was high in the order of bare area, Zostera bed deep, Zostera bed shallow. After December 2016, those were almost the same. That's because the height of Zostera marina was small and the shoot density was low due to feeding damage. So this graph shows the relationship between Zostera marina shoot density, height, and flow velocity. So there is a negative relationship between shoot density and flow velocity and shoot height and flow velocity, and it can be inferred that the flow velocity is not a sufficient condition to determine the distribution of seagrass. So these graphs show grain size and ignition loss. The ignition loss shows basically organic carbon. So we analyzed them in June 2015 and August 2017. So grain size at Zostera bed, deep and bare is similar, and larger than that Zostera bed shallow. The organic matter was high in the order of Zostera bed deep, bare area, Zostera bed shallow. So direct drainage by flow may not be a direct cause of bare ground. The next point, so I'd like to talk is environmental improvement to eliminate growth inhibitory factors. So before the presentation, so we checked the condition. So where seagrass distributes. So this part, so we show I showed the type of seagrass restoration in Japan. So type A is do not improve the environment. transplant or seed. The type B is after stability, the sand surface transplant or seed. So before presentation, so we showed the difference between the seagrass bed and the bare area. Especially this is different about the flow velocity. So this means if we protect and stability in the sediment, especially sand surface. So I guess so it is better. So type C is after raising the ground, transplanting or seed. So I will show why we need to raise the ground. So basically, it is about the light condition. So this is the result. So number of cases by seagrass restoration method in Seto Inland Sea, Japan. So unfortunately, type A seagrass has have decreased or been disappearance. Type B seagrass have increased, just one case. Other case, seagrass has decreased or been in disappearance. Type C, seagrass has increased area or shoot density. In Japan, it is difficult to form a seagrass bed with transplantation or seeding technology alone. So the next point I'd like to talk to reveal useful and inexpensive materials for making seagrass or seaweed beds. So if there is lack of light conditions for seagrass or seaweed at undersea ground, we improve light conditions to rise the underwater ground using sand or rock. So basically, in the sand, seagrass distribute. In the rock area, so seaweed distributes. So this is conventional seagrass seaweed bed creation materials. So natural rock used for breakwaters and seaweed beds. Sea sand or dredged soil used for seagrass beds. However, they are becoming difficult to obtain. So this shows regulations for breakwater and sand or rock materials. So one safe materials is the sediment must meet soil safety standards for humans and animals in a laboratory setting. So materials from which organisms can germinate is demonstration of seaweed growth by experiment and analysis of overhead water, etc. are helpful. Stationarity materials is use materials with a large particle size and a large specific gravity. This picture shows image map of artificial seaweed bed. So we constructed artificial seaweed bed between natural seagrass bed and fish reef. They unite the ecosystem connecting the existing fish reef further offshore and the seagrass bed closer to the shore. So this part of the study, seagrass bed construction materials. So to evaluate whether seaweed forms naturally without transplant plant and fixedly in the artificial substratum, and whether the bed is functional in attracting fish by comparing the physical difference between prepared material and natural material located nearby. Second is to evaluate the functionality of seaweed beds by analyzing the effects of an uneven shape of seaweed substratum at about 50 centimeters on fish attraction. Evaluation method is impact on the surrounding environment, formation of seaweed bed, function of seaweed bed. So this picture shows construction material of seaweed substratum, steel-making slug and lower alkalinity steel-making slug were new seaweed substratum material being studied. Natural rock and artificial rock are reference materials. Those are traditional seaweed substratum material. This table shows composition examples of steel-making slug. The ratio of calcium oxide in steel-making slug is higher than that of natural rock. That means if we enter the steel-making slug in the water, pH is rising. So this is our study site, Iwakuni, in the Seto Inland Sea in Japan. So Iwakuni is located near Hiroshima. So this table shows the construction of the seaweed substratum. So we performed the construction 4 times in about 36,000 square meters using 120,000 cubic meter steel making slug from 2013 to 2018. The first construction was to study the possibility of using steel-making slug. The second was to study about the physical and chemical differences of steel-making slug. The third was the possibility of using ferromangan slug. It is a different type of slug. The fourth was to study biodiversity. So after fourth construction, so it is very big seagrass substratum compared to other artificial seaweed bed in Japan. So we can compare we can study biodiversity, including the genetic diversity. So this graph shows the number of seaweed types and the cover rate in first construction. So the number of seaweed species gradually increased more than other materials and surrounding natural seaweed beds. So the number of the seaweed population grew gradually increased with seasonal variations. So, and there was little different from other materials. In November 2015, November 2014, the average rate became higher than the surrounding natural seaweed bed. This picture shows change in natural seaweed around artificial seaweed bed. Chrome is one of the species, is a dominant species in the surrounding natural seaweed bed. This picture shows change in constructed seaweed bed. So seaweed grew gradually, and seaweed species were sargassum, were basically the succession. So brown, green, and red algae attached on stimulating slug. So this graph shows attached macrobenthos on the algae and substratum. So macroalgae fish eat the macroalgae on the leaf or on the seaweed. So the attached biomass in the converter furnace steelmaking slug substratum is typically larger than in natural rock, artificial rock, and surrounding natural seaweed beds, and has the function of becoming a feeding ground for fishes, etc., similar to surrounding natural seaweed beds. So after we created the seaweed bed substratum, the shoreline seagrass bed expanded. So left picture shows a photograph in May 2006 before constructed seaweed bed. So we were not able to confirm seagrass distribution using this photograph. So right picture shows a photograph in December 2015 using drone. So after constructed seaweed bed, so we can recognize the seagrass distribution. So this picture shows the result of fishing net. So before construction, November 2012, there were just 6 species, 14 fish. After construction, species and population are higher than before the construction. So there were a lot of evil stinger and firefish. Evil stinger is a very expensive fish in Japan. So this picture shows result of a diving survey. So there are a lot of octopus. So basically, the octopus dig the steel making slug. So living in the steel making slug. So this is the picture. So okay. So the next point. So I'd like to talk to clarify why the restoration of seagrass or seaweed bed is not progressing in Japan. So this is studies on regulations for the seagrass bed and the tidal flood environment and development. So it is necessary to consider the fact that the foundation does not determinate due to the outflow physical condition and the structure biological condition maintained on the foundation can support creatures such as algae and by varies. The current design standards of seaweed bed substrate in Japan do not require construction materials to be stationary within 10 centimeter, unlike breakwaters. There are many types of living organisms and the range of living conditions in the same natural environment with normal variation. It is very important to consider the acceptable range of conditions. So this figure shows the relationship between construction area and the cost of the current seagrass substratum. If seagrass bed and tidal flat are constructed in soft ground or in deep places, improvement of the ground is required for the breakwater, etc. So ground improvement is done by sand drain, sand compaction, etc., and promotion of thick and dense material. So this is setting regulations for seagrass beds and tidal flat. First, material safety and characteristic. I have time, so I can't explain all. So all materials used for seaweed bed construction meet safety standards. So the grain size of substrate material is within the range where the target organisms can live. So second, securing the function of seagrass bed and tidal flat, it is important to achieve the growing conditions of organisms. Growing conditions vary depending on the type of organism. So it is necessary to narrow down which organisms are targeted. In order to secure the function of the seagrass bed and tidal flat, it is important to maintain the substratum both vertically and horizontally. Function may change depending on the thickness of the seagrass or the seaweed substratum. So we think thinking deformation of the substratum and the original ground outflow. The final point, I'd like to talk how to analyze the origin of organic carbon in sediments. So although there are many studies on the amount of carbon dioxide absorbed by seagrass or seaweed, but it is unclear what is the origin of the carbon stored in the sediment and how much do seagrass beds contribute to the carbon stored in the sediment. So methods for investigating the origin of seagrass include genetic distance between seagrass beds, carbon, nitrogen, stable isotope ratio, and environmental DNA. So it is difficult to qualitatively evaluate the origin of organic carbon in sediment by any method. I will explain about the stable isotope. So carbon and nitrogen have stable isotopes with different mass numbers, atomic weights, but the ratio differ depending on the environment in which the plant grew and the organism that the animal ate. Therefore, the fate of seagrass or seaweed is clarified using the stabilized top ratio as an index. So next, I will explain about environmental DNA. So environmental DNA is derived from living organisms released into the environment. By collecting and analyzing environmental DNA, so it is possible to quantify the presence or absence of organisms and the amount and number of individuals. So the purpose of this part of study, so although same studies has already used environmental DNA to evaluate the amount of seagrass DNA in sediment, the contribution of seagrass to carbon content cannot be quantified from the amount of the eDNA. So the purpose of this part of the study is to clarify the relationship between the amount of DNA and organic carbon content of seagrass in simulated sediment in laboratory experiment and estimate of seagrass uptake organic carbon in sediment using environmental DNA and stable isotope in Hiroshima Bay in Japan. So this is study site. So basically we studied in Hiroshima Bay. So we obtained the sample from seagrass sediment area and river. So in the seagrass bed, we obtained sediment, seawater, and distributed Drosera marina. In the offshore seagrass bed sediment area, we obtained sediment. In the river, we obtained river water. So we analyzed organic carbon contents from the sediment and distributed Drosera marina. So we analyzed the stable isotope from the sediment, seawater, river water, and distributed Drosera marina. So we analyze the eDNA from the sediment. So this is method of experiment in the laboratory. So firstly, the cell marina simulated sediment and artificial seawater were placed in a 50 milliliter tube and shaken at 20 Celsius degree. So we use the kaolinite and glass beads as a simulated sediment. So we removed the organic carbon from the simulated sediment by treating it at 900 Celsius degree or using hydrogen peroxide before putting it into the tube. Secondly, sampling was performed periodically from 14 days to 413 days. Thirdly, after extracting DNA from simulated sediment, we quantified the Drosera marina of DNA by quantitative PCR. So finally, after freezing, drying the simulated sediment, the amount of organic carbon was quantified. This is the result of organic carbon contents and environmental DNA in seagrass and offshore in the sediment. The carbon content of sediments in the offshore sediment area, which had a high organic carbon content throughout the survey period. ranged from 427 to 2,163 micromolar carbon per gram. On the other hand, the sediment carbon content of seagrass beds ranged from 61 to 532 micromolar carbon per gram. It was a significant difference. So there was a period when Drosera marina DNA was not detected in the seagrass bed, but it was 500 copies from 1,000 copies per gram in the seagrass bed, and from 100 copies per gram in the offshore sediment area. There was no significant difference between the two sites. So regardless of the type of simulated sediment, the large that amount of Drosera marina installed, the higher the carbon content. In addition, the carbon content was higher in the rhizomes than in the leaves of Drosera marina, and there was a significant difference. The amount of organic carbon increased, especially in the rhizome from 15 to 100 days after the start of the experiment. It was suggested that decomposable organic carbon of Drosera marina was fixed in kaolinite. The DNA copy number of Drosera marina in kaolinite with 0.5 gram of Drosera marina was higher, but there was no significant difference between 0.1 gram and 0.32 gram. Using kaolinite as a simulated sediment, the relationship between the DNA copy number and the carbon content of Drosera marina was this formula. They are result of carbon and nitrogen stable isotope. So sediment area is offshore was close to the photoplankton derived of carbon of seawater and in the seagrass bed sediment. The territorial of carbon in river water and Drosera marina were different from those in the offshore sedimentary. It was suggested that the ratio of carbon origin in the offshore sediment area was higher than that of seawater photoplankton origin than land or seagrass origin. So this result of estimated Drosera marina carbon fraction. So the estimated organic carbon content of Drosera marina in the sediment was 34% and 8% on average in the sediment of the seagrass bed and offshore sediment area, especially respectively. Except for the period when Drosera marina DNA was not detected in the sediment, there was no significant difference. On the other hand, during June to August, when the drifting amount of the Drosera marina and the vegetative shoots from the seagrass bed increased, the amount of organic carbon in the sediment did not increase. So this I finished my presentation. So this is the quiz. So three. I prepared the 3 questions. So what is blue carbon storage? Secondly, what is the conditions for seagrass growth? So thirdly, how do we make seagrass or seaweed bed substrate dam? So the answer is the blue carbon is the term of the carbon captured by world's ocean and coastal ecosystem. So seagrasses, mangroves, and salt marshes along our coast capture and hold carbon, acting as something called a carbon sink. The second question, what is the conditions for seagrass to grow? So one is seagrass bed which supplies seeds should be located in the neighborhood. Second, it is being in the hydraulic conditions to which seeds are supplied. Thirdly, seagrass habitat is suitability. Habitat suitability is physical and chemical factors. So we compared environmental conditions between seagrass bed and Bay Area. So we improved light conditions to raise the undersea ground using sand or rock. But recently we studied about recycled materials. So especially in steel making, slag, and dredged soil. So this concludes my presentation. Thank you for listening to me for so long. Thank you.
Thank you so much, Professor Kenji Sugimoto, for sharing just now. Now we will have a brief Q&A session. Participants are welcome to direct your questions to our speaker. Okay, Professor.
Mani,
Yes.
I have one question.
Okay, sure.
Hi, Prof. Kenji Sugimoto. I'm Dr. Suzy from UITM. First of all, I would like to thank you for becoming our speaker for today's webinar. And from your side, I've seen that you have studied this since 2013. Until now, you're still studying it, Prof? And I wonder, do you have your students to go into the ocean? How do you conduct your experiment? Like, I mean, you're going to collect your stones or what, or your seaweed. How do you actually have your students going into the ocean, like having hands-on application at the site? That's all from me.
Thank you. Thank you for question. So basically, so when we go to the field, so we went to sometimes just me or other professor. So I want student to go with me together. So but unfortunately, it is difficult to dive to get the sample. Then we ask the professional to get the sample, but just to get the seawater. So basically, student got the seawater. But I asked a student where student need to get the sample. Basically using if on the coast it is easy to decide the point, but in the on the sea, but basically using the boat, it is difficult to set to decide the point. So then we use the GPS. So we decide the point to get the sample. So anyway, so this is very complicated. Sometimes students didn't want to go with me that because my college basically student need to take a class every day. So my study site, so it takes 2 hours to go to the field from my college. So especially we go to on holiday. So this means the uh, student may not want to go on holiday, but I ask students. Sometimes I order to student to go with me.
So, Prof, your students is how many students do you have working on this project? Are they undergraduate students or postgraduate?
Basically, undergraduate students sometimes so one my level is basically 8 or 9 students per 1 year. Sometimes graduated student. Now I have one graduated student. So she studied about this blue carbon. So especially recently we want to know. So we have to estimate how much is the carbon dioxide from the seagrass or seaweed. So it is so, but sometimes fisherman grows wakame to eat in Japan. So this when we estimate the blue carbon, it needs the store in the sediment. If we eat the wakame seaweed, so just remove in the sea. So this means we cannot estimate the growing the wakame to make the fisherman make the wakame. So, but now it is the opportunity to estimate from the wakame. So that because have you eaten the wakame? So basically,
Yes,
so basically we how do you say so? So wakame include the arginic acid and fucoidan, very healthy contents. So the arginic acid and the fucoidan sometimes flow from the seaweed. So we estimate the content of arginic acid and fucoidan.
Okay, thank you, Prof. I'll pass this to our MC.
Okay, so there is one question in the chat box from Nur Hidayah. So the question is, are Malaysia seawater suitable for seagrass or seaweed reproduction?
I'm sure. So I have not gone to Malaysia, so I don't know the Malaysia conditions in seawater or seagrass, but I guess so. The temperature of seawater in Malaysia is higher than in Japan. So this means it is worst condition for seagrass or seaweed. So this means so I guess so. The specific seagrass or seaweed may distribute in Malaysia around on the coast. Sorry, I'm not sure about the Malaysia coast of in Malaysia.
Okay, because I'm not sure too, because we rarely heard about seaweed production in Malaysia. Okay, so we have a few questions from our committee, from my team. So the question is, if we can store the blue carbon, how does climate change impact the environment?
So this is just my opinion. So in this in this discussion, especially in climate change, so sometimes I answered yes. Sometimes I asked I'm not sure. So that because it is very difficult to estimate about the carbon dioxide. So most of some of researcher told me it is very important to make the seagrass bed or seaweed bed. This means so the seagrass and seaweed may how do you say this between include the organic carbon. So, but we have to estimate or evaluate how much the seagrass or seaweed bed contribute to disturb to how do you say? I forget the English word. Sorry. So anyway, so we have to evaluate. So sometimes some researcher may evaluate higher for blue carbon. So that because so some researcher want higher estimation of blue carbon, but blue carbon named just from since 2007 by United Nations. So this means we have to study more about the blue carbon. But unfortunately, recently there are few researchers to study the seagrass or seaweed bed. So that because if we study about the seagrass or seaweed, so sometimes we hire the diver or sometimes we hire the boat staff. So this means it costs a lot of money. So if we study the seagrass, including the blue carbon, so we have to pay a lot of money, so more expensive than other studies. So especially land study. So, but we have to study about blue carbon.
Okay, thank you so much. I can see that Anna has raised hand. Do you have any question to ask to our speaker?
Yes. Thank you so much. I'm Anna Kidani from NITUC, and then I have one question about the seaweed. What is the main difference between having natural seaweed and artificial seaweed bed, or is there any some difference about the result because of the seaweed?
And thank you for asking the question. So we have to think what if when we use recycled material or other natural rock material, so we named this is artificial seaweed bed or seagrass bed. But so we need, this is very higher conversation. So we have to think just we named natural and just artificial. So basically, I guess it is the same between natural and artificial seaweed. Basically, seagrass affect basically physical condition, especially grain, for example, grain size or the surface condition. But on the other hand, so it's okay to be different between natural and artificial seaweed bed. That because natural, most of people think natural bed is higher potential than artificial bed. So, but yes, if it takes a long time, so seaweed bed, artificial seaweed substratum change the natural conditions. So this means so we need to wait a lot of time. So we don't rush to estimate about the artificial seaweed bed.
Okay, thank you so much.
Okay, so that's all your question, right? Okay, so there's one last question for you, Professor. So the question is, what factors influence blue carbon burial rates? Factor for the blue carbon burial.
Basically, it is very important about the temperature, water temperature, and the right condition. So this means so I have to think. So when, for example, if we want to increase the blue carbon, so we have to make more seagrass or seaweed bed. And sometimes it's okay to make the mangrove. So we have to think the place is much for specific seaweed or seagrass species. So we have to basically we can not change the temperature, water temperature. We can just control the light condition and the flow condition. So this means so if we rise the bottom. So this means light condition is higher, but on the other hand, the flow condition is lower. That because the near the land, so the wave condition is worse than the offshore. So this means we have to think, we have to check around the surrounding the natural bed. So we need to design to build to make the seagrass artificial seagrass or seaweed bed.
Okay, so the factors involved the surrounding, right? The temperature, the mangrove and everything. So thank you so much for the Q&A, Professor. So we will proceed to next part. We will be having a exciting session for the participant. Please get your mobile phone ready to enter the quiz. You can also scan the QR code that's showed on the screen. Good luck, everyone. Winner of this quiz will be given prizes. Do make sure you are trying your best. 5 minutes will be given to the participant to enter the quiz. We will start in a few minutes.
Mana tu?
Okay, we will start the quiz now. A reminder to everyone that the winner of this quiz will be given prizes. So do your best and try to be top scorer to get prizes from us. Similar names at the top of the list board. Kenji, Jaya. To see the winner. So we will Kaijun is leading. Using your book. Alright, everyone, do your best. These prizes, of this quiz will be given prizes. So please make sure that you could get the top score to be able to win. Currently, Kenji is leading. Looks like he has answered all questions correctly. All answers. As by Azam. Jaya is still chasing. The winner be familiar names or different ones. the leaderboard, followed by Kenji. On the second place, let's see if Kenji can beat Kaijun. Dato and Samira is chasing. PG. Looks like Kaijun has answered all questions correctly. A total score of 19490. Shazmi is still in the second place. Let's see if can beat Kaijun. Kaijun is still currently the top scorer for this quiz. Kaijun is still leading. Let's see if one can beat him. Come on, everyone. Beat Kaijun and be the top scorer. Looks like Kaijun is still leading. And the quiz in a few minutes. So please do your best. Kaijun is still leading. And one, do your best because we will give prize to those who is the top scorer in this quiz. We will end the quiz in a few minutes. Okay, we will end now. Okay, we'll end the quiz now. So the winner for this quiz is pretty predictable. It's Kaijun. Congratulations to the winner of this session. Please contact our team later. Before we end our last session, all participants are required to turn on your cameras for our last photography session with Professor Kenji Sugimoto. I will pass the floor to our technical team.
Hello everyone, please open the camera and get ready for our photography session. All right. Okay. 1, 2, 3, smile. Okay, one more. Okay, 1, 2, 3, smile. Okay, last one, freestyle. Okay, 1, 2, 3, smile. Okay, thank you. Thank you everyone for your cooperation. I will pass this back to Wani.
All right, thank you so much, Mahira. So before we end our first session for today, towards the end of the quiz, it remarked our first session had ended. Once again, a big thanks to Professor Kenji Sugimoto.
Thank you.
Okay.
Thank you for inviting the summer camp.
Okay, thank you so much. And thank you to everyone for participating in this session. Ladies and gentlemen, we hope you enjoyed today's session. And we are excited to see you again in tomorrow's session. Before we end, do remember to fill up the attendance form provided in the chat box below. The attendance link will only provided only in Webex and YouTube Live chat box. Quick reminder to everyone, the theme for tomorrow's webinar is Industrial Affluent Wastewater Management. The meeting's link will be blasted on WhatsApp group and email today. Please be alert and attend tomorrow's session. Please make sure all participants fill the form before you leave the meeting. We do not provide the link on WhatsApp. With that, I end this meeting today, and participants who have filled the form may leave the meeting now. Thank you, everyone, and have a nice day.